Hello students, today in this video we will study about force on two parallel wires. We are going to consider two parallel wires. Let me say this is one wire and this is another wire. I allow current to flow through one of the wires. Let me say this wire is A. And the current is flowing through, and let the current flowing through this wire is I1. According to magnetic effects of current, we know when current flows through a conductor, a magnetic field is set up or produced. So how do you find out the magnetic field direction? Using right hand thumb rule. Now accordingly, when you see, if I hold it like this and the current is going upwards and the magnetic field is acting into the board, it is acting inward. You know that the magnetic field we can represent as concentric circles. Yes, let me draw more concentric circles, and this represents the magnetic field. Now what is the magnetic field? We used Biot-Savart's law, and also we used Ampere's circuital law, and we derived that magnetic field due to a straight conductor B is equal to mu naught I upon 2 pi r. I said to you in the video related to the straight conductor, there is a pi in this equation. So this is due to a straight conductor. Let me call this as equation number 1. Now what is this magnetic field due to? It is due to the first wire. Okay, due to the first wire, the magnetic field produced by this, we can call it as B1 and current as I1. So I will put here subscript B1 and I will put I1 here. And now what I am going to do, I am going to bring another wire. Yes, this wire is here, and I bring another wire, another parallel wire B, and this wire is also going to carry a current. Yes, let me bring another straight long conductor. Okay, so let me bring it like this. Fine. Now the current through this wire, this, let us call this as wire B, and the current flowing through this is I2. Yes, and let us say it is lying at a distance D. Okay, distance between the two wires is D. Now look here, B1 mu naught I1 2 pi r. I can change this r as D. D is distance between the two wires. Now the magnetic field due to the first wire on the second wire, right? Now it exerts a force on it. Now we already studied about the force acting on the wire. Our discussion is force. Okay, what is the force formula? F is equal to B, the magnetic field, I into L sine theta. And I said to you, theta, when it is perpendicular, we can set it to be equal to 1. So the formula is F is equal to B I L. If I want force per unit length, I may have a very long wire, but I take, for example, in 1 centimeter, what is the force acting? Or in 10 centimeter, what is the force acting? So I can say force per unit length is equal to magnetic field into current, B into I. You understand what I say? Here F upon L is nothing but force per unit length, that is B into I. Okay, now current is flowing through, magnetic field is produced. Now what is the force exerted on the second wire, the B wire? This is the second wire. On this wire we are going to calculate. So let me put a mark here. Fine. F upon L is equal to B into I. Okay, now watch carefully. Force per unit length is equal to B, magnetic field due to what? Which one is producing? The first wire is producing. So B1. Now, if the second wire is a plain wire, not current is flowing through, nothing will happen. Now in this wire, a current I2 is flowing through. Because of that, there will be a force on that, and that is because the magnetic field due to the first wire is having an impact on the second wire and current in the second wire. Is it understand this point? Force upon L is B1 I2. Why is it B1 I2? Magnetic field due to the first wire and magnetic field, this is going to be the second wire, current is flowing through. Now imagine, only I2 is there, current is flowing through, naturally a magnetic field will be produced, right? And this magnetic field and this magnetic field are interacting with each other. And this magnetic field and this magnetic field exerting a force on each other. And because of that, we say F upon L is equal to B1 I2. So what is B1? That is mu naught I1 upon 2 pi D. D is the distance of separation into I2. Or simply I can say mu naught I1 I2 divided by 2 pi D, that is force per unit length. And this is the formula you will find for force per unit length, and this is nothing but Newton per meter. Keep remember this point, this is Newton per meter. Now if the first wire is exerting a force on the second wire, according to Newton's third law, what will happen? For every action there is an equal and opposite reaction. So what will happen? The second wire will exert a force on the first wire. Then what will be the magnitude? Let us find out now. I will take the case here B2. Yeah. Now I will say magnetic field due to the second wire is mu naught into current in the second wire divided by 2 pi D. Distance of separation is same. Okay, call this as equation number 2. Yes, now force per unit length is equal to B into I. We know this much. Now, forget about this first wire now. Take only the second wire. Again you think here, right? I draw a concentric circle. Again I draw a concentric circle. And again I draw a bigger concentric circle, right? And now this is influencing on this wire. Again take right hand thumb rule. Now you see like this, it's also going inward, and here it will come opposite. Middle if you take, it will come outward. Now keep this carefully here, and the magnetic field is due to the second wire. So I will put here B2, and it is influencing the first wire, the current in the first wire, that is I1. So that is equal to mu naught I2 into I1 upon 2 pi D. This is nothing but mu naught I1 I2 divided by 2 pi D. So this is the same thing, force per unit length, which also comes to be the same. In either way, Newton's third law is holding true. The force due to the first wire on the second wire is equal and opposite due to these two. Okay, so you have to understand this concept. Two parallel wires are very important because you will find that cables are above. You know, the cables are moving, they are all parallel to each other. So that is a magnetic field produced, right? That is why sometime you will hear a humming sound. Oh, yeah, that is because of the magnetic field being produced. That's why distance is separation is there. There's a particular distance of separation. Yes, you have to understand this concept of two parallel wires. If current flows through in both of them in same direction, they will attract each other. They will attract each other. This is called parallel current. Okay. Now, if suppose current is in opposite direction, one above, another comes down, they are called anti-parallel. When they are anti-parallel, they will be repulsive. The force is attractive or repulsive depending on the direction of the current flow. Yes, with this we have completed a small unit now, and we will move on in the next video with the next concept. Thank you.